In part 2 of PIC Computing, A-Level Computing video number 23, we're going to look at how to subtract one binary number from another. When we're subtracting two decimal values, so we might have 36 take away 19, we should know that we have to do something called borrowing. So we can't do 6 take away 9, so we borrow one from the next column to the left, and when we borrow one we take away one from that column on the left as well. So 16 take away 9 we know is 7, 2 take away 1, not 3 take away 1, 2 take away 1 is 1, and we have our answer. So how do we subtract one binary number from another? Well, first of all we lay out our sum, similar in the way to we would in denary or in addition of binary. So if we had 111 take away 101, what we should do is put our binary base 2 number system up above, and we can actually probably do this one on our heads. And it's always a good idea to try and do that first of all, and then you can check to see if your final answer is correct. You can double check in effect. So 111 in decimal is 7, 4 plus 2 plus 1, and 101 in decimal is 5. So we should come out with an answer in decimal anyway of 2, which would be 10 in binary. Just like the binary addition, we have rules for binary subtraction. So A minus B should give us an answer usually, or we'd have to borrow. So 0 take away 0 in binary is answer 0, and we don't need to borrow. 1 take away 0 is 1, and we don't need to borrow. 1 take away 1 is 0, and we don't need to borrow. So those simple rules should help us do this first one. So 1 take away 1 should be 0. 1 take away 0 is 1, and 1 take away 1 is 0. So we get our answer of 010 or 10, which is 2. So we can double check we've got the right answer there. So that's just following the simple rules. So subtracting binary becomes a little bit more difficult when we have to borrow values from the next left hand side column. So let's take a look at an example that does that now. 110 take away 101. We can see we've got a 0 here when we try to take away a 1, which we can't do using the rules that we've got here, so we need to introduce a new rule. But first of all, we should check to see what we think the answer should be, so we can double check that we've got the right answer later on. So 110 in decimal is 6, and 101 in decimal is 5, so we should come out with an answer of just 1. So 0 take away 1, what's the rule for it? Well, we can't do it, so we borrow 1 from the previous column. So we cross out what was in the previous column at the top, and we replace that with a 0. And we take that 1 over to this column where we need it. And then we've got it. We've got 10 take away 1. And when you have that, the answer is 1, and there's no more borrowing to be done. So 10 take away 1 is 1, 0 take away 0 is 0, 1 take away 1 is 0, and we've got the right answer because 001 in binary equates to 1 in decimal, so we've double checked that we've got the right answer there. Where it might get even harder is in an example like this, where we need to do 0 take away 1, so we need to borrow, but there's nothing to borrow from previous columns. So for this one, the expected answer should be 3, because we have 1000, which is 8 in binary, take away 101, which is 5 in binary. So we're expecting 3. What do we need to do then? Well, we go along to the left looking for the value that does have something that we can borrow from, and then we borrow along. So we cross that out, and we have 1 carried to the next column, borrowed, and then the left hand side column where we borrowed from becomes a 0, and we just keep doing that all the way along. So now we've got 10 take away 1, which we can do, which should give us 1. We've got 1 take away 0, which will give us 1. We've got 1 take away 1, which should be 0, and 0 take away 0 again, which is 0. And we've got the right answer because 11 binary in decimal is 3. Have a go at these ones now for yourself. There's the truth table, but I'm going to take that away and pause the video at this point and try and rewrite the truth table for yourself, because that would be a useful thing to do in an exam. When you get to the top right hand side one, that's quite an interesting one to do, and see if you can figure out why. So pause the video at this point. So this top right hand side one was quite interesting. Let's take a look why. We've got 1001, take away 1101. And the reason being is that the number on the top is actually smaller than the number on the bottom. So it should eventually turn out like it does here further down, where we end up with 0101, take away 1101, and we will come out with 1 take away 1, which is 0, 0 take away 0, which is 0, 1 0 take away 1, which is 1, but then we're left with 0 take away 1 on the end. So we end up with a negative number. So we can write down, for the sake of this presentation, minus 100, but in computing, and when we think about what a computer understands, it understands ones or zeros. How can it understand the minus sign? Well, that's something we'll need to look at in the next video. There are 2 different ways to represent negative binary, and we'll take care of that in the next video. Bye for now.